Welcome to Formula 1 Maths. This is lesson 1.1 for the AQA Certificate in Further Mathematics course. For this lesson, we are going to combine 5 topics. So let's get started. In the AQA Level 2 Certificate in Further Mathematics course, the following topics will be tested implicitly: number and number system, simplifying expressions, solving linear equations, algebra and number, and expanding brackets. In this lesson, we are going to revise these topics by solving a few questions. Question 1. Simplify the expression 6x squared yz times 3xy cubed. It is best to rewrite the question in this form. By doing this, you are kind of grouping the common variables so that you can apply whatever rules you need to apply to them. So now let's go and use the laws of indices to help us to simplify this further. First of all, you can see that 6 times 3 will be 18, and then we need to simplify the x squared times x, and also the y times the y cubed, and then the z. So we know that there is supposed to be a 1 here that we don't normally put, and 1 here. So using rule number 1, we can simplify the whole expression to this. And then simplifying it further will give us 18x cubed y to the power 4 z. Let me state here that these two steps, the first two steps, are not necessary. If you can move straight from here to this place, please do. But if these two steps will help you, please do as well. Question 2. Work out the following without using a calculator. So we are going to apply bit mass to this, and that means we need to solve this part, the division part, first. And how do we do that? We need to change this sign to multiplication and then flip this over. So we're going to get this. And by doing that, we can now reduce some fractions. So we have 3 going here, 1, 3 goes into 9, 3, and then we have 5 goes into 5, 1, and 5 goes into 10, 2. So now we are left with 7 over 10 minus 1 over 1 times 2 over 3. This reduces to 7 over 10 minus 2 over 3. We need to solve that. And how do you solve that? So we've got 7 over 10 minus 2 over 3. So we draw a line here. Our LCM of 10 and 3 is 30. Now 10 goes into 30 3 times. 3 times 7 is 21. Minus 3 goes into 30 10 times. 10 times 2 is 20. And so that's how I got this here. And then 21 minus 20 is 1. And finally, our answer is 1 over 30. So that's question 2. Question 3. Given that x to y is equal to 5 to 4, and y to z is equal to 3 to 7, work out the ratio x to z in its simplest form. We start by writing the first ratio as x over y equals to 5 over 4. This implies that x is equal to 5 over 4y. We have just made y the subject. And then we can label that as equation 1. Now we do the same thing for the second equation. Then we'll make y the subject to get y equals to 3 over 7z. And then we label it as equation 2. We now go and substitute equation 2 in equation 1. And so when we do that, we are going to get 5 over 4 brackets 3 over 7z. Then we expand the brackets to get 15 over 28z. We can rewrite this equation here as x over z equals to 15 over 28, because this is 15 over 28 times z, and the z coming over here would divide. And because we've got this, our ratio is simply x to z is equal to 15 to 28. And that's the simplest form. We cannot reduce this fraction further. All right. So that's question 3. Question 4. Simplify this expression. So again, we were going to rewrite this as 14 over 4 times a to the power 4 over a times b cubed over a to the power 6 times c cubed over c. Now we have combined them in this way so that we can put the common variables together. Now we are going to use the laws of indices again to help us. We are going to use mainly rule number 2. And before I go on and use it, let me remind you that rule number 2, which says that a to the power m divided by a to the power n, can be written as a to the power m divided by a to the power n. So this here is the same as that, and that will give us a to the power m minus n. So if you apply that to these parts of the expression, you're going to get this. Then we can reduce this fraction here by cancelling out. So 2 goes into 4, 2, and 2 goes to 7. Now we can go and write this way. Now we have seen that this is a negative power. We don't normally want a negative power in the numerator. So we're going to use rule number 5 to rewrite b to the power minus 3 as 1 over b cubed. And then when we do that, we get this. And then simplifying everything nicely by removing the multiplication signs gives us 7a cubed c squared over 2b cubed. Question number 5. Factorize this expression. So we've got 3x squared y plus 12xy cubed. Now looking at the two terms, this one and this one, the highest common factor of these terms will be 3xy. So that can come out of the brackets, and then I'll have, for this term here, I have only x remaining, because if I now multiply this one by that, I'll get this. For the other term, I've got 4 and then y squared. And so this is how we factorize that, and that's how I got this one here. Question number 6. Simplify this expression. So here, because of this division here, we are going to change that into a multiplication sign and flip this one over. So we're going to get this here. We can now reduce some fractions. So 3 goes here, 1. 3 goes into 6, 2. 5 goes into 5, 1. 5 goes into 10, 2. So now get this. I'm going to bring up the laws of indices again to help us here. So if I do that, now look at the a squared times a, we are going to use the first rule here, rule number 1. And then we have b squared divided by b. So b squared divided by b, we are going to use rule number 2. And then for c and c squared, we are going to use rule number 1 in the denominator, so that c and c squared will remain in the denominator. So if you do that, you're going to get this. And then when we simplify that, we're going to get a cubed b over c cubed. So that's question 6. Question 7. Write as a single fraction x over 5t minus 3y over 4t plus z over 2t. So what we do here is to find the common denominator of 5t 4t, and 2t. And that will be 20t. So we put our common denominator down like this. How many times will 5t go into 20t? That will be 4. Multiply the 4 by x to get 4x. Then how many times will 4t go into 20t? That will be 5. Multiply the 5 by minus 3y, and you're going to get minus 15y. And then finally, how many times will 2t go into 20? That will be 10. Then 10 times z, that will be 10z. And so this is a single fraction required. Question 8. What we need to do here is to find the lowest common denominator of 2 and 5. That will be 10. Then we multiply each term by 10. So this term by 10, the 2x by 10, and this last term here by 10. So when we do that, we get this. Now you can see that I can reduce this fraction here. So 2 goes to 1, and 2 goes to 5. And then for this side, 5 goes to 1, and 5 goes to 2. So now it reduces to this, which is a very nice linear equation that we can solve easily. So let's simplify that further. To get this, expand the brackets, you're going to get this. Then rearrange by putting the like terms together, and you get that. Simplify further, you're going to get 26 equals 19x. Then solve for x, you're going to get x equals to 26 over 19. Then you can change that to mixed fraction, and that would be x equals to 7 over 19. And that is question 8. Question 9. The largest angle in a triangle is 8 times as big as the smallest. The third angle is 45. Write this information in the form of an equation. Solve the equation to work out the sizes of the 3 angles. We start by saying that let the smallest angle be x. In that case, the equation that we are looking for is x plus 8x, which is the largest angle, plus 45 is equal to 180, because the sum of angles in a triangle add up to 180. And that is the equation that we are required to form. We can reduce this to 9x plus 45 equals to 180 degrees. And this is it. This is the final equation that we are required to write down. And then it says solve the equation to work out the sizes of the 3 angles. So 9x plus 45 equals to 180. Take 45 to the other side. Simplify that. And then solve for x. And that will give you 15. So the smallest angle is 15. That means the largest angle will be 15 times 8, which is 120. And so we conclude that the sizes of the 3 angles are 15, 45, 120. Question 10. A is 45% of B, and B to C is equal to 2 to 5. Show that 50A is equal to 9C. So A is equal to 45 over 100B. Let's simplify that. We're going to get A is equal to 9 over 20B. And let's call it equation 1. Then let's rewrite this ratio here in this form. And then we can make B the subject to get 2 over 5C. And we can call it equation 2. We can now go and substitute equation 2 into equation 1. And when we do that, we're going to get A is equal to 9 over 20 times 2 over 5C. We can reduce some fractions here. 2 goes to 1, 2 goes to 10. So we are left with A is equal to 9 over 50C. we can rewrite this as A over C is equals to 9 over 50. And that means we can cross multiply to get 50A equals to 9C. And that's what we are required to show. Question 11. P to Q is equal to 3 to 5. Work out P plus 2Q to 4Q, giving your answer in its simplest form. So let's rewrite this ratio again in this form. And if we make P a subject, you're going to get 3 over 5Q. And we can call that equation 1. We now go and substitute equation 1 into the following ratio, which is the same ratio here. So if we do that, we're going to get 3 over 5Q, which is P that we got here, plus the 2Q, which is there, 2 for Q. Now the best thing to do here is to multiply all the terms by 5. So what I mean by this is we've got 3 over 5Q plus 2Q to 4Q. If I multiply that by 5, I must multiply that by 5 and that by 5. So by doing that, I can cancel out this one to get 1 and 1 here. And so the whole equation becomes 3Q plus 10Q to 20Q. Simplify that, get 13Q to 20Q. Then we can divide through by Q to get our simple ratio 13 to 30. And that is the end of this lesson. Thank you for watching, and I'll see you in the next video.